this week, decisions, right? If statements. Let's look at what Buzz has. All right, so looking at our activities, go down to the decisions lesson. There's the decisions assignment right after it. Decisions lesson. Let's click on that and see what it has for us. All right, we are talking about the power of if. Two little letters, one big word. To be or not to be, right? That's a yes or no. It's a true or false. You decide to be or not to be. The power of if lies in your ability to make a decision. If a stove is hot, then you can decide not to touch it, which I would recommend you make that decision. If you're old enough to vote, then you can choose to vote. If you want to know what happens to Hamlet, well, then see the play, or don't. You're going to make that call. You also get the right code that tells the computer what decisions you'd like it to make and when. So we're going to learn how if statements are used. We're going to talk about Boolean logic and identify what relational operators we must use. So if statements. Sometimes you make decisions based on emotions or gut feelings, but other times you use logic. Well, computers don't have emotions. They don't have gut feelings, at least not yet. Instead, they rely entirely on logic. In fact, logic is one of the world's most powerful tools that programmers can use. So the source of logical programming is in the if statement. It's one simple word. So let's look at using this type of logic. If you want to see a concert, you buy a ticket. Buy a ticket. Decision statements are based on condition statements that start with the keyword if. If it's cold, then you dress warmly. If you like spicy food, then eat it. If not, then don't. It's that simple. Let's look at the next page. Let's look at the relational operators. So it says choose the correct relational operator for each statement. So this is how we tell the computer to choose. You have to use the right operator. Like if your age is something, 18, then you can vote. Here's our choices. Greater than, less than, greater than or equal to. This is how we do equal. Notice there's two equal signs. When we use one equal sign, that is to assign a value to some variable. Like age equals 18. If we did that, that would assign the number 18 to the variable name age. But if we're wanting to check if age, the Boolean logic with the relational operator, we're going to use the two equal sign because that's different than assigning it to age. This exclamation mark equal, that means not equal. If age is not equal to 18, then you can vote. Or less than or equal to. Well, we know you can vote once you turn 18 and when you're older. So we would use greater than or equal to. If age is greater than or equal to 18, then you can vote. Great job. Your logic sensors are quite impressive. Let's look at the next example. If water is 100 degrees Celsius, it has reached the boiling point. All right. So look at that, less than 100 degrees Celsius. No, greater than. Well, at greater than, it is boiling, but it's not saying it's boiling. It says it's reached the boiling point. It's reached the first temperature that it would be boiling at. So that would be the equals. If water is equal to 100 degrees Celsius, it's reached the boiling point. Submit that. Now, if it just said the water's boiling, we'd say greater than or equal to, because if it's hotter than that, it's also boiling. But this just said it has reached boiling point. Remember, a computer's got to look exactly at what is typed. The logic will use exactly literally what's there. Let's look at one more. If height is 48 inches, you cannot ride the roller coaster. If height is less than, right? Because if it equals 48 inches, you can ride. That's usually the minimum. If the height is less than 48 inches, you cannot ride. Just less than. Let's see. Great job. All right, there's four more there. I'll let you go through that. Data usage is something or other compared to your data plan. You pay an overage fee. So I'll let you go through those. So here's how an if statement would look like. And I know that looks like just a dash. It's supposed to be an equal sign because over here it has greater than or equal to. So Boolean condition right there. This is a Boolean condition that will compare two values with the relational operator. It'll either be true or it'll be false. So it first sets the height, variable name height, equal to 48.5. So then it checks it. If, there's that Python keyword, if height is greater than or equal to 48, print you can write. Right. So in this case, 48.5 is greater than or equal to, so it should print you can write. So here's a little chart that shows us arrive at the fair. If height is greater than or equal to 48 inches, yes, ride the roller coaster and go get ice cream. If it's not true, then it just goes straight to go get ice cream. Right. So there's our flow chart that kind of help thinking about the logic that's in the statement. If is a yes or no. Is it true or is it not true? True or false? If it's true, you do this and then come back and continue on. If it's false, you just continue on. And there's George Boole, who came up with Boolean logic. He is credited with laying the foundation for the information age. He was the inventor of Boolean logic, and he developed the basis for what computers use to make decisions, which is the condition statement. So without him, you would never be able to search videos with cats and teacup pigs or sloths. You're welcome. Thank you, George. Appreciate that. So yeah, there's lots of mathematicians that are involved in computing, the creation of computing, and what the necessary tools are to do that. Let's look at page 4. It's true the if statement is one of the most powerful tools a programmer has, but also causes a lot of errors. If you're not used to thinking with Boolean logic, you're going to run into confusing problems. So the more you practice, the more you'll get it, and the less problems you'll have. So let's look at this if statement. Define main, so that starts our program. We're setting the value of A equals to 20 and the value of B equals to 30. So as we go through these statements, the first thing it does is print facts about A and B. Now, it's going to do that regardless. There's no if statement before that. That's just the next line of code. First, we set this variable, we set that variable, and we print this. So that we'll expect to see that. Then we start hitting the if statements. If A equals B, remember that double equal sign just means equal. A equals B. Well, does A equal B? No, 20 does not equal 30. So it should skip this print statement because this is false. When it checks this if statement, it's false. So it should not go to the print. It should just skip and continue on to the next if statement. If A is not equal to B, well, in this case, 20 is not equal to 30. So we expect it will print A is not equal to B. If A is greater than B, print A is greater than B. So is 20 greater than 30? No, we expect it to skip this one. Is A is greater than or equal to B? It should also skip this one. Is A less than B? If A is less than B, if 20 is less than 30, it should print this, right? Because 20 is less than 30. And it's also less than or equal to. So we expect this. And then that's the end of our program. So when we run that, we should expect it to skip this one, print this one, skip this one, print this and this one. Let's see, run program. Facts about A and B. A is not equal to B. A is less than B, and A is less than or equal to B. See, it skipped these if statements where this was not true. Not true. Now we can go back up here and let's say they're both 30. Now it should print A equals B. Should skip not equal to. It should skip greater. It should print greater than or equal to. And it should print less than or equal to. Should print those three statements this time. Let's run the program. A equals B, greater than or equal to, less than or equal to, because it is equal to. So it prints those three. So it's just checking whatever you type inside the if parentheses to see, is that a true statement? Is that false? Do I need to execute the code that comes after the if statement, or do I need to skip it because this is a false statement? Okay, look at this one. Define main. Age equals 20. If age is greater than or equal to 18, print you can vote. Well, 20 is greater than 18. Let's see. You can vote. How about if we change this? Let's say our birthday's tomorrow, right? 17.9999. We know that's practically 18, but the computer, well, it doesn't print. When I run that program, does not print. You can vote because it's looking literally. It literally has to be greater than or equal to 18. This is not equal to 18, and it's not greater than 18. It's less. But if we change that to 18, now you can vote. Very literal, exactly what you put in there. Define main, num days absent. This is a variable, and we assign it the value of 0. And then we're checking if this is equal to 0, print you have perfect attendance. So we expect that to say you have perfect attendance, right? No, we have an error. What is the error? Think back to our relational operators. We said we use an equal sign to assign a value to a variable, which we did right there. But here, if we're using it in an if statement, we have to have those double equal signs. That's how we use the Boolean operator, the relational operator, to check if it's equal. Now, when we run it, you have perfect attendance, right? A single equal sign is only to assign values. The double is to check in your if statement. All right. Let's look at this one. The if statement, define main. We're going to assign the cost a value of 20 and the discount a value of 0. And then we're going to say on sale. That's another variable, and we assign it the value y. And then we check if on sale is equal to y, then change the discount. Instead of being equal to 0, let's change it to $2.85. Then the cost, which was $20, will be whatever it is, the cost minus the discount. It will start at 0, but if it's on sale, it's going to make the discount $2.85. So print the cost is, and then the variable cost, whatever it calculates to be, in statement. The cost is $17.15 because if it's not on sale, it's $20. So you'd probably be better in your program, say on sale equals input is the item on sale. Yes, no. Quote in that. All right, so now look at this. It changes to an input statement. Is the item on sale? And right here is very important. This tells them what options to put on the input statement. Y/N. If we don't have that, let's look at that. Let's just run the program. Is the item on sale? Well, if we say yes with a Y, it calculates it at $17.15. The what? Now it doesn't say is the item on sale. Say yes, it is. Yes, it is. Well, it didn't give us any discount. It's back to $20 because the computer is checking literally for this Y. Anything that's not just that literally Y, it's going to act like it's not true. On sale was not equal to Y. It was equal to yes, it is with an exclamation point. So it's not the same thing. So it helps to put in here exactly what you're looking for if you're going to have an if statement that checks their input. Now I know, oh, I should just put a Y. So when I hit OK, it gave me the discount. I can't even put, if I put a capital Y, that's a capital Y, no discount because it wasn't checking to see if it's a capital Y. It was just checking to see if it's a lowercase y. So make sure that whatever you put here is exactly what you're checking for. Lowercase y. Have to put a lowercase y to get the discount. $17.15. So think about how to make your program useful for somebody else running your program. You don't want to have to go in and change the code to on sale equals in, or change it to yes or y if it's true. So, make it an input statement. So it can be easy for someone to check the price. Is it on sale? Yes, $17.50. All right, let's look at this last one. The if statement, define main. Print, let's go to the movies. So that's going to print because that's the first thing in the code. Ticket cost is $7.25. Snack cost is 0. So now it's like order popcorn. That's a variable name. And we're assigning the value of whatever's input right here. Input popcorn, Y or N. I'd probably put a question mark in it. Popcorn? Do you want popcorn? Yes or no? If order popcorn, because that's the variable right there, is equal to Y, because that's one of the two choices, then change the snack cost or add to the snack cost $3.75. Because maybe you've got more if statements you're putting. Do you want to order a drink? Do you want to order candy? So each one of those would take whatever the snack cost was coming into this statement and add $3.75 to it. Because you order popcorn now, so we're going to add $3.75 to whatever your total already was for snacks. Because maybe you already said yes to a drink, maybe you already said yes to something else. It's going to take the total cost and it's going to add the ticket cost and the snack cost together, and then print. Here's how much your ticket costs, here's how much your snacks, and here's the total cost with those three variables. So let's run that. Popcorn, Y or N? Y. Okay, $7.25 for the ticket, $3.75 for the snacks, $11 my total cost. I say no popcorn, 0 snack cost, and it's just the cost of the ticket. So you could add more if statements, add more snacks. It says expand the program by including more snacks like drink or candy. So you can play with that and see if you can add more options and just add to the cost of what it already was. Keep the cumulative total. You don't want to just say snack cost equal $3.75 and then down here to order a drink, you say snack cost equal $2.50. Because if they ordered both of them, they should be paying $3.75 and $2.50, right? So your choice on that. All right, and that's the last of it. Page 5 just tells us to read this lesson, practice using Python, which you can do right there on page 4. You can practice using Python right here. And then complete the decisions quiz, which is the next assignment, which you can go to it right here. Or you can go back to the menu and go to it. But there is, see, mine's a retake. I've already done mine. I've already completed it. But right there, you'd have a start button. But that is this assignment right here. There's your lesson. There's your assignment. Next week, we'll be writing a program with this. So if you want to get in there and start looking at that now, you can do that. You can go in there and take a look at next week's lesson and start working on writing that program now if you like to, or you can wait till next week. But this is the only day we meet. It's a B day this Friday. This is an A day, the only A day this week. So I will let you guys go. We will see you next Monday.